Welcome to all. Once again, that is a very important topic of the theory of automata formal language, that is NFA to DFA conversion. This topic is important with respect to the university examination and GATE examination also. Every year one question asks in GATE examination, that is 1 marks. So this topic is most important. We move on the NFA to DFA conversion. First we see what is the NFA, then what are the steps we follow NFA to DFA conversion. Now this is the formal definition or this is the mathematical definition of the NFA. One more thing we can conclude that the power of NFA and the DFA are same. NFA is an incomplete machine. NFA cannot be implemented. That are the 3 main points which is important in GATE examination. And for the GATE examination, this point is most important, asks the GATE examination. Transition function with the help of state, and we provide the input, and we can move 2 to the power q number of state. In NFA, we move only the single state, but in DFA we can move only the single state, but in DFA we can move 2 to the power q number of state. So this point is important. Here is a same, that is the starting state, and F is a final state. Or now where 2 to the power k is a subset of q. We move from the example. Any DFA can be converted into the NFA. Now the first step, we draw the transition table, and which state are they generated, consider as the next state. This is the state, this is the transition table of the NFA, and when we draw the transition table of the DFA, then simple, that is the DFA. Now it start from the Q0 and input A and B, and here is a Q0 and here is a Q1 and Q0 and Q1. When we draw the any NFA to DFA, then start from the initial state, and which new state are generated consider as the next state. It means here is not a new state. The new state is a Q0 and Q1, and we check the transition function of the Q0 and Q1 on A input. That is Q0 and Q1. So what is the transition? That is again Q0. Q0 and Q1, what is the transition we found? That is Q0, Q1 and Q2. Q0, Q1 and Q2. So it means one extra new state are generated, that is Q0, Q1 and Q2, and consider that is Q0, Q1 and Q2, and we check the transition on A and check the transition of B. If any new state are generated, then we consider as the next state. Now Q0, Q1 and Q2 on A, that is again Q0, and here is a Q1 on B, that is Q0, Q1 and so no new state are generated. Now this is the transition table of the DFA. We can also draw the function of that function. It means how many states are available, that is Q0, Q0, Q1 and Q0, Q1 and Q2. These three states contain in the DFA. This one is the initial state, and in NFA final state, now this one is the same as the final state into the DFA, and you can draw this simple transition table. Now Q0A, that is A, and B, that is here is a B. Now Q1, Q2A, that is the A, and here is a, that is the B. Now here is a A and here is a B. So this is the DFA of this NFA. So very simple step, and we follow the any NFA to DFA. This question is asked in university point of view, but we move from the gate point of view. Now this one, because this question important, here is a epsilon closure, epsilon move. So first we find the epsilon closure. Epsilon closure of all state. Now 1, 2, 3, 4. What is the epsilon closure? That is very simple way. With the help of epsilon closure, any state can move all state, then all state is the epsilon closure of that particular state. And by default, self state is the epsilon closure of all state. It means 1 is the 1 epsilon closure, 2 is epsilon closure, 3 and 3 epsilon, and so on. Now with the help of epsilon, one state can move 3. It means 1 and 3 the epsilon closure of the one state, and with the help of epsilon closure this state can move also 2. It means 1, 2, 3 is the epsilon closure of the state 1. Now with the help of epsilon closure, 2 state can move anywhere? No. It means there is no another state are add in epsilon closure of state 2. Now epsilon closure of the 3 and 2, and epsilon closure of 4, no movement of the epsilon closure. Now we find the transition table of the NFA. Transition table of the NFA. That is the 0 and 1 and state from 1. When we check the state 1 transition on 0, then we check the transition of that particular state closure. It means we check the 1, 2 and 3 transition 0. Now for one state 0 transition, that is the 2. For 2 state 0, no transition is available. For 3 state 0, that is the 4. 2 state found, that is 2 and 4. And what is the here? The closure of 2 and 4 we include here. So 2, what is the closure of 2 and 4? That is 2, 3 and 4. That's simple. We move another. We again check the 1, 2, 3 and transition of 1. For 1 transition is not here. For 2, 1 transition is here, that is state 2, and for 3, any state transition is not available. Now 2 and 4. Now what is the closure of 2 and 4? Again 2, 3, 4. Similarly 2. So what is the 2 closure? Again the closure of 2, that is 2, and the we check the transition of the 0, and 2 we check the transition of the 1. For the 2 transition, for the 0 transition on state 2, no transition is available. It means here is a 5. Now here is a 5. For 2 state 1 transition is available, that is 2 and 4. And what is the closure of 2 and 4? That is 2 and 4, that is 2 and 4. And what is the closure of 2 and 4? 2 and 4. Now, here is by 2 and 4 and 2 and 4, 2 and 4. Now, we check the transition of the 3. Now, the transition of the 3, that is check the transition of the 0, and 3 check the transition of the 1. Now, to check the transition of the 3, it means we check the transition closure of the 2 and 3 and 2 and 3. For the 2, what is the transition of the 0? No transition available from the 0, and from state 3 we find the 4, and from the 2 transition 1, what is the closure of the 4? Closure of the 4 is 4, and for the 1 transition, 2 transition 1, that is 2 and 4, and 3 transition for 1 is not here. So, now the closure of 2 and 4, that is 2 and 4, and similarly 4, and the closure of 4, that is closure of 4, that is again 4. The transition of 4, 0, and transition of 4, that is 1. Transition of 4 on 0, that is 3, and transition of 4 on 1 inputs, no, that is the 5, and the closure of 3, that is 2, 3, and here is a 5. Now, this is the transition table of the NFA, and any transition table of the NFA, that is very easily convert into a DFA. How we can convert? We follow the same approach. Now, 0 and 1, and start from state 1. Here is a 2 and 4, and here is a 2 and 4. So, one new state are generated, that is transition table of the DFA. One state new find, that is 2 and 4. So, now next state, that is 2 and 4. 2 and 4. So, what is the transition on 0? That is 2 and 3. On 2 and 4, what is the transition of the 1? Again 2 and 4. So, what is new state generated here? State 2 and 3. So, 2 and 3 is a new state, and we check on state 2 and 3 transition 0. We check 2 and 3 transition on 1. Now, here is a 2 and 3. The state is a 4, and here is a 2 and 4. 2 and 3, 2 and 3 is 0, that is 4. 2 and 3 here, 2 and 4, here is 2 and 4. One state remaining, that is new state are generated, that is 4, and on 4, 0 transition, that is 2, 3, and here is a 5. Any new state generated? Yes, that is known as a 5, 5, and here is 5, here is a 5. Now, this is the final answer of the any DFA are converted into the NFA. This is another example. For better understanding, any NFA are converted into the DFA. Here is a NFA, and we are going to convert into the DFA. Now, DFA A and B. And what are the initial state? That is Q naught, and next state that is Q naught and Q1. So new state generated, that is Q naught and Q1. So new state considered as a next state. This is the procedure by which any NFA are converted into the DFA. That is Q naught Q1, and we check Q naught Q1 for the transition A and transition B. Now Q naught and Q1, again here is a Q naught and here is a Q naught, Q1 and Q2. So what are the next state? Next state, that is the Q naught, Q1 and Q2, and here is again Q naught and here is again Q naught, Q1 and Q2. Now this is the transition table of this result. That is very simple, and you can try this question by posting this video, and I think you can easily convert any NFA into a DFA. What is this step? Firstly, we draw the transition table of this. Then with same concept, we can convert NFA into a DFA. So what is the transition table of this machine? That is the transition 0 and 1. Now that is the Q0. Now Q0, here is a Q0 and no 1, and what is the 1? That is the Q1, and that is the Q1 on 0 transition, that is the Q1, and here is a Q2, and any other transition, no transition is available. Now here is, and here for the one transition here is a Q2 and one transition, only this no transition is now Q2. For Q2 0 transition, that is the Q1, and 0 transition here is again, that is the Q naught, and the 0 transition and Q1 Q naught for the 0 transition, and for the one transition here is a Q1. Now this is the NFA transition table, and with the help of this table we can easily convert any DFA. Now the DFA transition table, that is very simple, A, B, and that is the DFA. Start from the initial state, and any new state are generated, consider as the next state. Now here is a Q naught, Q1 and Q2. Q1, Q2 is a new state, consider as the next state Q1 and Q2. Now Q1 and Q2, this one, it means Q0, Q1 and Q2. Here is a Q0, Q1 and Q2, and here is a Q1, Q2, here is a Q1, Q2, Q1, Q2. So what is the next state generated? That is Q naught, Q1 and Q2, Q naught, Q1 and Q2, that is Q0, Q1 and Q2, Q0, Q1 and Q2, and from one transition, that is Q1, Q2. No new state are generated. Now this is the DFA are complete. This is the NFA. This is the transition table of the NFA, and we can easily convert into the DFA. This is the transition table of the DFA, and you can easily draw the machine. Okay, friends, thanks. We meet into the some more interesting topic of the finite automata into the next lecture.